now we're going to transition to talk about Graviton and deep dive into Graviton. Again, for those who are just tuning in, my name is Martin Yip. I'm the Senior Manager for Amazon EC2 Compute and Networking Services. And joining me today is Stephanie Xu and Ali Sadi. Can you please introduce yourself?
Yeah, hi everyone. Thanks for having me. I'm Stephanie Xu. I'm Global Head of Go-to-Market and Business Development for Graviton. I lead a team of Graviton specialists and specialist solutions architects around the world. And our job is to work with customers and partners to help them in adopting Graviton.
My name is Ali. I'm a Senior Principal Engineer in AWS. I've been here for about 6 years, and since I joined, I've been working on Graviton.
All right, so let's talk about AWS Graviton processors. So AWS is unique in that it builds its own processors. Can you tell us a little bit more about Graviton and remind us why we decided to invest in our own CPU?
Yeah, absolutely. So Graviton processors are custom built by AWS using 64-bit ARM Neoverse cores, and they're designed and optimized specifically for cloud-native workloads. And what many people don't realize is that Graviton isn't actually the first chip that AWS developed in-house. It was actually the AWS Nitro system back in 2017, which enabled a new approach to hardware and software virtualization, and it now powers all modern EC2 instances. And the reason why AWS decided to develop its own processor comes down to what our customers have told us they're looking for, and that's more choice, the ability to optimize performance, and lower the cost of building and running their applications, and reducing their carbon footprint. And the best way we could meet those needs was to innovate at the silicon level. And so through each generational launch of Graviton, we've pushed the envelope in terms of performance improvements, lower cost, and energy efficiency, and our customers are responding to that. So I'll walk through a little bit of a generational journey. So with the first generation of Graviton processor back in 2018, our goal was to establish broad ARM64 ARM64 support and enable our partners to build compatible solutions. And just a year later, we released second-gen Graviton 2, and this is where we were able to introduce significant improvements in price performance and energy efficiency over existing x86-based processors. And customer adoption for Graviton 2 really exceeded our expectations, as we saw some of our biggest AWS customers like Epic Games and Snap, really lean in to take advantage of those benefits. And so now, we're on Graviton 3. This has been available for over a year, and we've proven that we're invested in the space and doing this consistently. And with macroeconomic conditions increasing the focus on optimization, more and more customers are now adopting Graviton as a way to really achieve those goals without having to sacrifice innovation or growth. So today, Graviton is used by over 40,000 customers, and they're enabling up to 40% better price performance, up to 20% lower cost, and using up to 60% less energy for the same performance.
Wow, those are amazing big numbers. Of 40,000 customers, 40% better price performance, 20% lower cost. Can we dive in a little bit about those benefits? Like, how was AWS able to achieve such big numbers and such big benefits?
Sure, building any chip is an optimization problem with some conflicting objectives. On one hand, we want the highest performance, but on the other, we want energy efficiency, a device that's manufacturable at scale, and one that's low cost. Okay. And so with Graviton, as Stephanie mentioned, we start with our Neoverse cores from ARM, and as you know, ARM has a long history in low-power devices like phones and laptops and many of the electronics around us. And then we work closely with them on the definition of that core, bringing our knowledge about cloud-based workloads to their knowledge. And we select a core we're going to use for Graviton, and we consider what system we're going to build around that core to make sure it performs all the way to its potential. While, for example, many people in the industry have been focused on simultaneous multi-threading, we've been focusing on providing full cores, which bring performance and security benefits. And then we start asking ourselves questions like, how big should the caches be? How much DRAM bandwidth should we attach? And all these have downstream effects in terms of how big the package is, for example, this, and how expensive the motherboard is, and other components. It's really easy to focus on stats and say, oh, the most cores, the most PCIe lanes, the highest frequency. But all those are likely the wrong optimization point when you talk about something at our scale, and it leads to something that doesn't really perform as well or has a high running or manufacturing cost. And we really want to focus the design on what can lead to the best price performance to delight our customers, not just stats. So if we consider these two CPUs here, this is a Graviton 3, and this one's a Graviton 2. They both have 64 cores. We could have put more cores there, but we looked at the number of DRAM channels that we could cost effectively build, the bandwidth of each of those channels, and how much we thought we needed for every core to perform well and not just spend a lot of time waiting for memory. And we chose 64 cores to get that optimal performance.
Yeah, the performance benefits and the price performance benefits are amazing. We heard this morning a ton of customers benefiting from Graviton, but it's more about just performance and price performance, right? It's also about sustainability. Can you talk a little bit more about that?
Yeah, I mean, the energy efficiency is just another facet of that optimization problem. I talked a moment ago about ARM's history and efficient microarchitectures, but let me spend a moment talking about the power of transistors. A Graviton 3 CPU has around 55 billion transistors, and every time one of those switches on or off, it uses a little bit of power. And that power is proportional to the frequency and the square of the voltage that the CPU runs at. Now, to get higher frequencies, you have to use higher voltages. And so really there's a cubic relationship between frequency and power. That means a little more frequency can actually quickly cost a lot of power. And with Graviton, we've built CPUs that get performance to doing as much as possible per cycle, so we can run them at moderate frequencies and be energy efficient. Also, the end-to-end ownership we have with Graviton allows us to take those CPUs and build efficient systems out of them with as few materials as possible. If you look at a traditional server, you have 2 sockets in every 1U server. But from the start of Graviton, we knew that sticking with just 2 sockets was going to use more resources than we would have liked. And so we did something that I don't think others have ever done, which is put 3 sockets in a single
That's
server.
really unique, yeah.
And to do that, we had to start with the Nitro card and make sure the Nitro card could talk to 3 sockets and not just 2. But it went further than that. The package that the silicon sits on had to be such that we could fit 3 side by side. The motherboard had to as well. The heatsinks had to be a different form factor. And the benefit we get from this is for the same amount of compute, we end up needing less material. Less material in terms of sheet metal for racks and for servers, fewer Nitro cards, fewer power supplies. And all those things not only reduce costs, but also just are more sustainable because we're just using less.
Yeah, and it's been really exciting to see how our sustainability-focused customers are meeting not only their price and performance goals with Graviton, but reductions in their carbon footprint as well. So Pinterest is one of those customers that's partnering with AWS on their environmental sustainability journey. And they view AWS silicon solutions, including Graviton, as well as our machine learning chips, Trainium and Ferentia, as playing a role in not only reducing costs at Pinterest, but also their broader sustainability strategy. So they recently moved their first production workload to Graviton, which was their caching tier of servers on Memcached, and they achieved 40% performance gains, and they're estimating $1 million in savings per year just for a single workload.
Fantastic.
And yeah, this is really just the beginning of Pinterest's migration project to adopt Graviton widely. Another customer that's focused on sustainability is Snowflake. Their goal is to provide the best data cloud with the lowest carbon footprint on the planet. And they recently completed the migration of their data warehouse to run on Graviton. And with that, they've been able to seamlessly reduce their customers' carbon footprint by an estimated 57% when they're using Snowflake Virtual Warehouse Credit. And they're also delivering a 10% performance improvement.
Yeah, so you mentioned 40,000 customers earlier, and Pinterest, Epic Games, and Snap just now. What are the type of customers that can definitely benefit from Graviton?
Yeah, so let me just pull up a slide here with some stats. But I mentioned earlier that Graviton-based services are now being used by over 40,000 customers, and that includes 48 of the top 50 EC2 customers. So some of our largest EC2 customers are now running substantial portions of their compute infrastructure on Graviton-based instances. In some cases, over 50% of their EC2 footprint is now Graviton-based. And what we're seeing is, once a customer has migrated one of their workloads, they learn what's required, and they see the price performance benefits, they're quickly identifying other workloads in their environments to move over. So we're seeing adoption across a wide range of industries, including software, financial services, ad tech, media and entertainment, and healthcare and life sciences. And there's a number of ways that they're adopting. So let me switch to the next slide here. So Graviton is available today now through 19 different EC2 instance families across all 31 public AWS regions. So whether your workload is compute intensive or memory intensive or storage intensive, we have Graviton instances that are most likely going to align with those requirements. And then Graviton's also available through a wide range of AWS managed services, including Relational Database Service, or RDS, Elasticache, OpenSearch, Lambda, and Elastic MapReduce, or EMR. Managed services are often kind of the easiest ways
Yeah.
to start adopting Graviton and achieving those price performance benefits with really little to no code change.
That's awesome. No, this is really the gamut of the entire EC2 portfolio, including accelerated computing as well. So what type of applications are customers running on Graviton?
Yeah, Graviton processors, they're general purpose. So that means they can be used for almost any Linux-based workload today, including web and gaming servers, media encoding, and in-memory caches. But I would say as far as where we're seeing the most traction, I'd highlight two key workloads. The first is across analytics and big data workloads. So customers are migrating their Spark, Trino, Druid, Hadoop clusters over to Graviton, and they're seeing great outcomes in terms of price savings and performance boosts. So a couple examples, Wealthfront, which is a fintech that provides automated wealth management services, they migrated their data processing workloads using EMR over to Graviton in less than a month. And with that, they were able to save 8 hours of data processing a day and save 20% over their previous solution. Another example is Zomato, who is an India-based restaurant aggregator that provides food delivery and recommendations for over 350,000 restaurants. They migrated their Trino clusters that power their insights for matching delivery partners to restaurants and providing accuracy on wait times. They migrated those over to Graviton to improve their overall query performance as well as lower costs. And because of the performance benefits of Graviton, they were able to improve their overall query performance by 25%, reduce actually their peak capacity requirements by 30%, and that led to overall 30% infrastructure cost savings. So a little bit of math.
Those are some really great outcomes, and
Yeah.
definitely analytics and big data are some key workloads that would be great for Graviton. But what other key workloads are customers running?
Yeah, so another common workload we're seeing customers migrate to Graviton are open source databases. So there's broad ARM64 support across the open source database landscape today, including MySQL, MariaDB, Redis, and Memcached, as well as across commercial offerings. So a great example here is Aerospike, which offers a multi-model NoSQL real-time data platform. When they're running on Graviton, their customers are seeing up to 63% better price performance, 27% lower costs, and they also looked at their carbon footprint impact, so they're estimating 49% improvement in carbon emissions per transaction. I mentioned earlier Snowflake as another example here. They're running their entire data warehouse platform on AWS, now on Graviton, and there's a lot more to come here. So SAP announced back in March that they're making progress porting their SAP HANA cloud offering over to Graviton, and they expect to start rolling that out in Q3 of this year.
Yeah, I love that even though we say 40% better price performance, many customers are seeing much more than that.
Yeah, that's true.
So are we seeing any other emerging workloads that are running on Graviton?
Yeah, I'd like to highlight machine learning workloads. We've been contributing to machine learning frameworks like PyTorch and TensorFlow to improve their performance on Graviton. ML frameworks like video encoding are two places where there's lots of low-level optimization and people have to get in there and optimize the code. We've been doing that for both of those. And for example, going from PyTorch 1.13 to PyTorch 2 on a C7G instance, we've seen as much as 3.5 times the performance.
Wow.
Just a huge jump.
That's a huge jump, yes.
And actually that makes C7G one of the best choices for CPU-based inference in AWS if you're not able to adopt something like Inferentia. One of the companies doing that is Modulate. Modulate's a company that uses machine learning to address the challenges of toxic language in voice chats and video game communities, and they use Graviton-based instances as the backbone of their real-time voice moderation technology and have reduced their machine learning inference costs by as much as 70%.
Oh, that's amazing. So how are customers getting started with the Graviton journey? Are they testing the water with smaller workers, or are they just jumping in with both feet?
Yeah, well, it depends on the customer. So some customers are going to focus on where they're going to see the biggest impact in terms of price performance and energy efficiency improvements. So they'll start with their workloads that have the largest compute footprint, because that's going to equate to the largest ROI. I mentioned earlier, and I'll just reiterate again, because a lot of people are often surprised by this, that some of our largest EC2 customers have taken this approach, and they're now running over 50% of their compute environment on Graviton. Yeah. But that said, not everyone starts there. We already mentioned AWS managed services earlier, but that's often where a lot of customers start because it's easy to migrate. Containerized workloads are also another low friction place to start, especially because there's already broad multi-architecture support across popular orchestrators and image registries that enable customers to run their containers on fleets that include both Graviton and x86-based instances.
Yeah, one great example is Stripe. They're a born-in-the-cloud company that provides payment infrastructure. And what they did is they started by picking a workload that they saw others try and had what is a meaningful amount of their spend. So in this case, it was Trino. Trino is an open source SQL engine. And they created a proof of concept just to see that they saw the same thing that others had. And then they wanted to make sure their builders could easily target either architecture. So they expanded their CI/CD pipelines to be able to build and test artifacts for not only x86, but also for ARM64 or Graviton. And after this, they tried replicating their production traffic that they were seeing to x86 on their existing cluster to an x86 one and a Graviton one. And the numbers really impressed them. They saw an average reduction of execution time by 54%. And not only did that mean they were finishing requests faster and they were having better response time, but it also meant that each instance could handle a lot more. Additionally, they saw fewer latency outliers and ended up being really pleased with both the performance and the cost reduction.
Yeah, I think customers just have to try. Take one engineer, take a workload, and just try. So are customers sometimes worried about whether the software will support Graviton and whether things are compatible?
They are, but it almost always turns out that worry is kind of unfounded. And there are really two halves to that question. I'm going to start by talking about first-party and open-source applications. And I've been in a lot of conversations with customers where the topic comes up. And in the most cases I've seen, whether it's Java or Python or Go or Rust or C or pretty much any other language, the code just ends up building and running. To aid developers in finding issues, we've developed a free tool called the Porting Advisor for Graviton that can scan source code, identify known code patterns and dependencies that lack ARM support. In most cases, if any changes are required, they generally are just getting to a newer version of that software. And we typically find that when customers do that, in addition to the security benefits of running the latest software, they also typically improve the performance of their existing instances, and so that they win either way.
Yeah, and we're also working closely with operating systems and independent software vendors, or ISVs, to drive support for the 64-bit ARM architecture. So in addition to what Ali was just mentioning, we also have strong support from popular open source and commercial Linux distributions and over 50 ISV products. And these are going to include container services, open source databases like we talked about, data storage solutions, data analytics tools, and developer automation tools. And so we've also created partner programs to help customers kind of more easily find these and more easily adopt Graviton. So the AWS Graviton Ready program provides customers with partner software solutions that have been validated, optimized, and certified to run on Graviton.
Yeah, I think definitely working with the community and having these programs to really get customers started fast is super important. So we've talked a lot about Graviton. Can you tell us what's new this year with Graviton?
Yeah, we've heard from a lot of customers, when they adopt Graviton, they just want to do it everywhere, in every region they're in. So now we have Graviton instances available in every commercial AWS region. We've also been launching some new instances. In February, we launched the Graviton 3, M7G and R7G instances that enabled customers that needed more RAM to use Graviton 3. And just yesterday, we launched C7GN and HPC7G. HPC7G is the first HPC-focused instance that we launched with Graviton. It's powered by the Graviton 3E, which is especially tuned for dense math operations like you find in HPC workloads. And we've also made the C7G generally available. It uses our 5th generation of Nitro card and delivers up to 3 times higher packet processing performance per vCPU compared to our current x86-based network-optimized instances.
That's amazing. 35% better processing performance for the Graviton 3E. Yeah,
the
amazing.
HPC workloads, yeah.
Yeah, for HPC workloads. So can you tell us how can customers get started with Graviton today?
Yeah, so I just pulled up a slide with some QR codes. So we have a number of resources available to help customers get started, whether they're looking to do this on their own or looking for some support. So first we have the Graviton Fast Start program. This is going to provide step-by-step migration guidance for a variety of application types, including serverless, containerized, database, and caching. We also have the Graviton Technical Guide, which is our GitHub repository that we are constantly updating that dives deeper into topics such as performance tuning and benchmarking. But for those customers that want more hands-on support to augment their teams or accelerate the migration timeline, I highly recommend engaging with a Graviton delivery partner. So these are systems integrators who are vetted and certified to support customers throughout the Graviton migration journey. For qualification of their workloads, to performance testing, to production ramp up, they can really step in at any point in that journey. And then in addition to Graviton delivery partners, we also offer Graviton expertise through AWS professional services globally. So lastly, I'm excited to share 2 free offerings because everyone loves free.
I love free.
Yes. The first is the T4G free instance trial that's available through the end of the year. All new and existing AWS customers can utilize up to 750 hours per month with the T4G.small instances, enabling developers to start building on Graviton at no cost. Second, and I'm going to flip slides here, is that we have a free virtual training coming up next month on July 12th called Graviton Essentials Developer Day. And this is going to dive deep into best practices for accelerating migration and development on Graviton-based instances, and go into topics like specific programming, language considerations, and testing and optimization techniques. So this is designed to be interactive, and it's an opportunity to engage live with Graviton technical experts. So highly encourage folks to register for that.
Great. Well, I love all the innovation that you've shared with us today, and I love all the tools and programs we have in place, including the free trial, including the virtual developer day to help customers get started. So customers, please use one of those QR codes to go to the link to the webpage and register. Thank you so much for your participation today. Next up, we have a customer video from Instructure that talks about their usage of Graviton and some of the benefits that they're seeing from Graviton. But again, thank you so much, Stephanie and Ali, for sharing your thoughts on Graviton today.
Thanks for having us.
Thanks for having us.
Always.